companies who are each established in our own ways, and through Earth05, we were lucky to get paired up and actually find a way where we can collectively make a huge impact. So what we'll do today is go through first of all each of our companies, so you get an idea of where we're each coming from and how we're contributing, and then focusing a little bit on the combined solution. And what we are asking for, of course, is investors to scale up, basically. So all of us have a product in the market and are making money in various ways. What we need is that final push and assistance in getting this out there and actually start saving lives. So yeah, as Maria said, please feel free to ask any questions. We will take them as we go through. You can ask directly to individual companies, or we can talk about the combined solution towards the end. So so with that, we should just share the vision. And yes, that's the one. The mission, Fabio, it went away again, I think. Right. So as I said, we are three companies here. I'm Peter Rasch from Dryp. From Pulse, we have Rania Habash, who is the Chief Medical Officer, and from Evodrop we have Fabio Hüther, who is one of the co-founders and the CEO. My role in Dryp is also as a co-founder and now a visionary officer, so not taking so much care of the day-to-day. In terms of what we do, what we try to show here is basically if you can imagine the water from rainfall running into the city from the hinterland in the Dryp solution. So at Dryp we are installing sensors. We are dealing with IoT sensors, but also whatever is out there and already existing. We're combining that with machine learning and prediction, so that we are able to show downstream what is coming, and also not just how much is coming, but also what kind of mix it is. And that is then taking into Pulse, who sits at the treatment plants. And Pulse water solution, as Rania will go into many more details in a minute, is all about really removing forever chemicals, but also basically creating clean drinking water from sewage, and using a really smart system, if I may say that. And then at the end of it, we have Fabio's solution from Evodrop, which is really reusing some of the outputs from Pulse. So the sludge, the fertilizer, and also the not so clean water, which is still clean enough for agricultural purposes, and then utilizing that and knowing what is coming again in terms of nutrients and so on. Fabio is able to mix that with various smart things to make it specific for specific crops. So through these combined solutions, we're really hoping to create something that can be both simply implemented, but also scale very quickly to any community out there, basically. So with that, I will start, because Dryp is at the end of it. So if you can take the next slide, Fabio. So basically what we say at Dryp is that we turn drops of data into sustainable solutions. And as you can see in the slide here, it's again the same picture. Sorry, next one, Fabio.
Yeah.
And what we are really doing is taking from the guessing out of wastewater. Today, wastewater is something that is in the cities, out of sight, out of mind. But we are really using sensors and using AI, machine learning, to know what is going on down there, how much it is utilized, and where the problems are. Right now, you only see it when things go wrong, right? And in this way, we are making it much more visible, and we are helping to make the climate adaptation of our cities into something that can work. So right now, our basic numbers are, we have a healthy turnover. It's growing at a rate of about 2 times a year, mostly as a SaaS. We have been profitable in the past, but have now been investing and expect to be profitable again next year. And our recurring revenue will be upwards of 9 million in a few years. And it's at the end of the day, think of it as increasing the accuracy of what's going on in our cities. Next one, please, Fabio.
Mm.
So again, this is what we're doing today is very much focusing on what the utilities have as their main problems. It could be overflows, it could be separation and flooding inside the cities, it could be utilization of their inflow to wastewater treatment plants and so on. And all of those are, you can say, is part of the big picture. So we are basically predicting the water flows into each of these and making it more efficient and pointing out how what the bottlenecks are and how they can be overcome. Next one, please. And an example here is really from what it might look like. So it's both sensors, as I said, but it's very much a software solution where we take simple information like water level and transform it into more complicated data through combining it with the rainfall and other things. So on the left, you see kind of a split into how much is sewage, how much is infiltration, and how much is inflow, and how much of that is supposed to be there and how much is not supposed to be there. And from that, we can make the consequence calculations and turn it into actionable insights where you can say both on an operational level, where should you go and fix problems that have occurred in your system, but also on a planning perspective, where should you focus your asset management. And next one, please. So right now we're looking to raise a round just for ourselves also, in addition to the combined solution, so that we can basically scale out of the Nordics where we are today, and take our first steps in the US where we see a huge interest, and also some upgrades to our. It's a little bit of specialist platform today. We want to make it more user friendly. And then at the end of the day, also just invest in marketing. So that's Dryp in just a few slides. I can't remember if there's one more, Fabio, is there? I don't think so. So yeah, so that's basically us. You're welcome to contact me or Dina, our CEO, if you want to know more about Dryp specifically. But otherwise, I think we should move on and talk about the Pulse and the role there. I don't see any questions right now for Dryp, so let's take them towards the end. So Rania, are you ready?
I think so. Yes.
Very good.
I'll share my slides if that's okay.
Yes, also fine.
All right, let's do it.
You share your own slides, or you don't want?
I can share my own slides. It's saying that only hosts can share. So are you able to allow me to share?
You should be able to do that. Try now.
It says only hosts can share in this meeting. Let's see, let me try one more time. There we go.
Always with the technology.
Well, every time you're giving a technology demo, right?
Yeah, exactly.
Okay.
Better when it's live.
So hopefully everyone can see my slides here, right?
Yes, it's a little bit small,
great.
but yeah, it works.
All right, what can I do to help this? Is that better?
I think it's okay. Yeah.
You think it's okay? All right.
Yeah.
Okay. Just to give context, I am filling in for the CEO of the company, so bear with me a little bit. Oh. Okay, I'm going to see if does that make it better?
Yeah, that's it.
Yeah. Okay, great. Okay, so Pulse is a civilization-changing moment for everyone, and they're very excited to receive the Earth05 prize for the 500 million lives. We feel that forever chemicals should not be forever. Diamonds should be forever, not chemicals. I'm going to tell a very interesting story about the founder, Eric Brugett. When he was growing up, he had well water in a very rural area here in the United States. And because the water wasn't safe to drink, it would give people diarrhea. To introduce myself, actually, I'm the chief medical officer. I'm a medical physician. I'm a medical doctor, a physician, and so the health aspects of clean water are super important to me. As a result of Eric's upbringing, they actually had to brush their teeth using Mountain Dew soda instead of the water because they couldn't drink it. And that's how important it is to have clean water. But this isn't just one town story. This is the entire world story, because every time we wash our vegetables or drink from a faucet, there's something called forever chemicals in the water. This is PFAS, and it's in 99% of us right now. Pulse can change that, though. It can change that for over 500 million lives. Why should we care about forever chemicals? Well, this is a hidden poison in your family's life. It has been tied directly to 8 different types of cancer: testicular cancer, kidney cancer, thyroid disease. There's a 30% decrease in fertility. This is a very big reason why there's such a big problem with fertility in the world right now. It creates weak immune responses. Birth defects, because it crosses the placental barrier, and it's found in almost all breast milk and umbilical cords. So these birth defects, preterm labor, developmental problems are a very big concern. And then, of course, everyone has these kinds of things in our lives: diabetes, heart disease, cholesterol. These are all problems that have been tied back to PFAS, or forever chemicals. And then at the end of the day, it costs the healthcare system billions of dollars to treat. So there's a big problem when it comes to water treatment. Right now, there are 4 different methods, or there are a couple of different methods. There's filtering, there's incineration, which uses heat, there's landfilling, but all of it comes back to us. The poison, it just gets kind of kicked down the road, but it's never actually eradicated. And that's the really big problem with PFAS. It's indestructible, essentially, until now. Because with Pulse, we can use electron beam technology that actually causes a molecular destruction. It breaks those PFAS bonds at the molecular level to make things safe again. It doesn't use heat. It is scientifically validated. It gets rid of all the toxins without any chemical residues left behind. This is a very important thing to remember here. No chemicals, no fire, no residue. This is a clean, sustainable solution to end forever chemicals forever. What's more, and I think Fabio is going to touch on this a little bit more, this is the segue there, is now, instead of just taking toxic sludge, which before, the purpose was to try to purify it enough that it can be buried again. Well, now instead, it can actually treat the toxic sludge so that there is no contaminant, and it becomes safe fertilizer instead. And now that safe fertilizer can be used to serve our populations. And this is super important because it's the plants that are grown in this fertilizer, then the animals that eat the plants, and then, of course, us who eat the animals and plants. So that's where, we want to make sure that the cycle is broken. There are 4 different ways that this water can be treated: municipal drinking water, industrial wastewater, environmental leachate, and toxic sludge. This is a very scalable solution. It's built in container-sized modules. It just takes 3 to 4 weeks to build these things and deploy them, versus the 18 to 24-month timelines with regular systems. So that's a very important distinction, that they've figured out how to make this technology modular and fast instead, and that makes it way more scalable. And these systems can process like 50 million gallons daily with 99.99% PFAS removal, and that just one module can serve about 2 million residents with just a single installation. It's a huge market, 1.3 million trillion for the TAM. And this is important because all the EPA regulations are occurring right now. And all of these companies and municipalities need to meet these guidelines by essentially 2026. So it is a regulatory tsunami, and Pulse is the only solution at this point ready to deploy at scale. So do we want a future worth inheriting? We want a place where clean water isn't a privilege, but a promise. We want to flush away the waste, but we don't want to flush away the waste. We want to make it a resource that can nourish life. We want to turn fines into fortune from the EPA regulations. And we want our children to grow up in a world that is chemical free. So thank you very much. If you'd like to get a hold of anyone, this is our contact information. Again, this is a very rare civilization changing opportunity, and we believe that forever should be for diamonds, not chemicals. Thank you.
Good punchline there, Rania. Thank you very much. All right. So yeah, so that's kind of the center of the solution, right? Taking wastewater, going through some of the traditional streams, but also really at the end of the day, as Rania pointed out really nicely, coming out with drinkable water and sludge that we can use for other things. So I think that points very nicely to you, Fabio, and the Evodrop solution.
Yeah. Thank you, Peter, for that. So yeah, let's kickstart our presentation from Evodrop. As Maria and also Peter kindly already initially mentioned, I'm the co-founder and the CTO of Evodrop. So our maxim is to create sustainable water treatments which are more aligned with the bionics of the physical and mechanical world, to have like the most impactful techniques which we can use for water treatment and water filtration. The journey of Evodrop started with a patent on ultra nanomembrane. It's a kind of a substitute to the obsolete reverse osmosis system. Everybody in the field knows, and yeah, the guys which are not directly from the field, to explain it, yeah, quite shortly, is that reverse osmosis produces somehow a lot of wastewater. This production of wastewater, or especially the amount, creates a lot of problems with fouling and clogging, because the plastic materials can at the end start to foul with biofilms, with kind of bacteria. They have not been to be kind of pathogenic, but the biofilm will then also clog the membrane, and you have to maintain and change it often. The other issue is with the scale, means the lime scale of the minerals, of the salts, etc., which will clog it. So, and we made a new kind of orbital osmosis flow. Means we have another direction and another pathway for the water, and our material is specially coated, means it's antimicrobial, means we don't have the problem with biofilming, and especially also with the scale problem I will explain later. Additionally, we have a nanoporous absorber. This is a disruptive technology also for activated carbon filter. Usually activated carbon filter have problems with channel building, means the water, likely as humans, we always kind of lazy and want to find the most easiest way. So how it's also similar to a synchronistic flow in the carbon filter. We made a kind of a fiber where we use a cellulose from the tree, mix it with graphene and also activated carbon, and this makes it much more dense and without any channel buildings, and producing more micropores. So compared, as like something an easy equivalent is the chlorine and especially the chlorine reduction value. So compared to normal CTOs, this carbon block filter, we have a 12 time higher adsorption rate. The next stuff is the malate acid complex. We built a technology which is a matrix on malate acid granular. This is also a disruptive technology on the obsolete ion exchange, means the water softening, especially in Europe, where we are from. As a Swiss-based company in Central Europe, it's very common to soften the water. For sure, we also have hard water, but in Asia and America and yeah, many other countries, they have a lot of scale issues. For sure, it's kind of a luxury and privilege problem. But through that technology, it doesn't have to be any more privileged, because through the malate acid, we don't have to install very complex water softening machine. It works with the patent is on a special dosing and releasing system, so we don't need any electricity. No wastewater is created. For instance, with a water softener, you use in a four-person household around about 100 kilograms of salt for the ion exchange, and you create around 20 to 30,000 liters of wastewater, depends on the technology. And we have no wastewater, no electricity, and no salt needed. We only require 1 kilogram of the malate acid, and this will treat a whole house for 1 year. Then here we have the next is a sputtering technology, where we make all filters, membranes, and technologies in a magnetron vacuum chamber in a mineral mix. So this mineral mix will then create a high redox potential, which is much stronger than the usual KDF 55 or 85. Through that, we can adsorb heavy metals and also kill viruses and bacteria. We used it also in next to water. In membranes and water filters. We used it in cooling water tanks, or during the pandemic was used for face mask. We have it also. We have some suppliers which we deliver for socks and shirts. So it's multi-phased aspect. Then the next one is a coating. Coating technology is where we can coat all surfaces to make them antimicrobial. We can use it on plastic as a raw granular. This raw granular then can be mixed with a normal. For instance, if you have a toilet seat, you mix 5 to 15% of our material in it, then it gets antimicrobial. The same we do in our cartridges. So everything which is plastic or similar to plastic, glass fibers can be used. Now we come to the technology which we have won together with Peter and Eric, the Earth05 Prize. It's the agriculture. It's a kind of an electrolysis cold plasma technology, where we treat the water, the irrigation water. The importance is that through that technology we are able to produce locally fertilizer, because through the air and the air which is surrounded by the machine and surrounded by everybody in each field, we pump into the system and mix it with the electrolyzers and the cold plasma, and through that we can then create from the nitrogen nitrates, we can create free radicals. The free radicals will be highly antibacterial, can kill pests and bacteria on the plants, in the soil, etc. And it has also antioxidative effect based on the ORP level, which the oxidant redox potential level, which we then bring into the irrigation of the soil and the plant. The pool technology is something similar, where we make the pool cleans without the usage of chlorine and bromine or any other chemical. So here you see, because we talked about a lot of different technologies and mechanisms, the focus here definitely is on the first two. This is how we highlighted it in darker blue. This is our cash cow. This is how Evodrop is making revenue with the point of use and the point of entry, especially with the point of entry with the patented malate acid, lime scale technology. And also from the point of views where we have different kind of drinking water systems, from small up to really big system, with going even into wellness and longevity. And on the right side you see the pool system and agriculture.
I think with that, you've gotten a little bit of an overview of the three different solutions, and basically how we're putting it together is, as we said early in the beginning.
What Peter already said initially in the dialogue is that we are representing the three companies which won the highest prize on the Earth05. There's 500 million lives. We were judged on the ROL, which is the return of lives, and the combination, as you have seen from our three technologies, are epochal and significant in all related aspects, because from Dryp, from all the IoT and AI sensoring and monitoring, what can be happen in municipalities, in cities, even in natural disasters, and then turning these water flows, these streams, which can be, for instance, for natural disaster, full of polluted water or overflown, or even through the sensor of Dryp, we could possibly see if a company or a factory reduce overflown with much of the substances in it, then it can be treated through pools. Eric mentioned to us that it's possible to run pools totally on renewable energy, which you see here on that. This can be combined with Dryp as well. So these two technologies with the pools and the plasma beam technology, what Rania explained before, is not only for PFAS. In general, it's much more than also PFAS. It can really bring you clean water. So you have drinking water qualities. I mean, there are other companies which may have a kind of an advanced technology, but mainly focus on one substances. And through pools, you have really a company which is multi-phase in all the water related attributes which are needed. So
that's right. Yeah. The main difference is that with PFAS, I mean, that's the one indestructible chemical, but you're absolutely right, Fabio. There are heavy metals in the water as well, contaminants, microbes, and those all go without saying that the electron beam destroys them all.
Yeah, exactly. With a high accuracy. So also that is really astonishing, because a lot of other companies, they proclaim 99.99 or however log 6%, but this is the best case scenario, right? You never know, for instance, with UVC lights or with other oxidation technologies, if it's really this 99%. And with the electron beam, you have this highly accuracy, which some other competitors can't really achieve even in worst case scenario, because this is where you have to give the safety, right? If water is out of
That's
standard.
Right. That's right. Yeah, with UV light, for instance, it only penetrates a few millimeters into the surface of the water, so it would never be able to, penetrate the entire container or facility. And then with other technologies, the chemical treatments, they leave chemical residue behind, which is now just poisoning the soil, which is your territory.
Right. So I think I can see some of the questions are more on the numbers and how we're going to scale this up. So even though we want to talk about the technology, maybe we have to move Fabio to how we're going to roll this out. Yeah.
Thanks, Peter.
Sorry.
All good. Yeah. So then we are already at the last part, which is the part of Evodrop, as you've seen from the sludge and the fertilizer, which can be produced by pools. Also agriculture water, and definitely then drinking water. The idea here is that we get the agriculture water, so it doesn't have to be drinking water quality. Then through our electrolysis and cold plasma technology, we are able to treat and irrigate that water. Means the technology we have can once be applied directly on the field, means in the direct flow of the irrigation system, or additionally, it can also be combined with a water tank and then highly increased in the potency. Means we absorb much more from the air, let it through the system, and in the air, as I mentioned, we can then produce locally fertilizer. There is no need of any nitrate fertilizer buying, because you can produce it locally. And also the other advantage is that you have really saved the water. It has like a depot effect. Depot effect means that it's safer for a few much more minutes or even hours, and not only go directly into the air, for instance, like with VOCs, what you have.
So Fabio, we only have about 10 more minutes. So maybe we can just say it quickly here. So what we are working on right now is a couple of pilot projects that we are hoping for, both in the US, in Spain, and in Denmark. So we're scaling. The initial scale is around 100,000 people per kind of setup of our combined technologies. And with that we can, and we can consume about or produce about 10 million liters per day. And then upscale that obviously through 2030, so we can treat up to 5 billion liters per year, and reach our goal of 500 million people lives saved or touched at least. And maybe one thing we didn't make so clear is also there's a huge saving in all of these technologies compared to how things are done today. So we will save on energy, we will save on chemicals, we'll save on how things are built in the environment and operated, and those savings are really substantial, and each of them actually a business case in their own right that we can get to. So I think that's basically the call to action right now, is that we wanna get to this, and we want to get your help in making this happen because it is a conservative business, and we need to we kind of need to convince people that it works, and even though individual parts work, we need to also show that the combined system works. Is that more or less the gist of it, Fabio?
No, thank you. In the picture, I would just mention it's one of the potential plants in Uganda, which will be interested. It's the Ministry of Water and Health, which is interested also in wanted to testing our combined solution. So as Peter already mentioned, there are a few potential interest sites.
Exactly. Yeah, we are all of us, I think, interested in talking more. So please just shoot through. Then there was a question to Dryp, and thanks for that, Mark, on how does this integrate with existing wastewater treatment systems and urban water management, and luckily it works really well. So that's our main revenue stream today, is actually just mapping out how efficient or inefficient the wastewater systems are working in the urban environment today. And basically what we're doing is digitizing these systems, and you can say in terms of customer acquisition on top of that, it's actually quite low, because we can go in on relatively small projects, small areas, and show the value of adding data to the mix and machine learning and analytics to make informed guesses. You asked about Africa and Middle East and so on. So right now we have to say we're only in Europe, and primarily even in the Nordics. We do, however, have one project in India, and which kind of shows that even digitization in India is of course up and coming. This is a really rural part of India where things actually can be digitized, and you can get really quick return on very small investments. So I think that's the short gist of that one. And I think that's a question for you, Fabio, in terms of advanced water purification, and are you planning on strategic licensing or hardware partnerships? Maybe it's both for you and Rania, but maybe you start, Fabio. In terms
Yes,
of the rollout,
definitely.
I guess.
Yeah, definitely. I mean, that's one of the parts from the patent. It's not only to use it as a marketing stringency, it's also that we have can collaborate with potential strategic partner. So through the patent, we have the ability to license these models, and yeah, also searching out for hardware and cooperation.
Yeah, I think that's true
Yeah.
for all of our companies. Actually, we're very kind of mission driven here. So whatever works in a way, right? I mean, whether it doesn't have to be our sensors, it doesn't have to be us actually doing the end client contact. It can be through others, as long as we make sure that we kind of revolutionize this little bit stagnant water industry that we're with, and people are open to these kind of changes. Yeah.
Yeah, and Pulse also has a model where they do joint ventures and partnerships as well. So they have an interesting model which I can elaborate on, in another conversation, where some of the upfront money is provided for the municipality, for instance, and then there's a joint revenue from recurring revenue and the equipment sale.
Yeah. Yeah, and that's actually also for our combined solution, and a little bit pushed by Eric. But look, these technologies are relatively cheap to combine and get up and running. Yes, electron beam does cost a little bit of money, but once it's there, it's capital incentive very early on. But then there's a return on investment, which is can be a few years or even less than a year in some cases. So to actually sell clean water by the gallon is a very attractive model, right, that we are exploring, I think, at the moment, right, Rania? We haven't actually got it under the hood, but it's close, and with a few utilities in the US.
Yeah, and the same concept applies for medical sterilization. Like I said, I'm a medical doctor. All the equipment that I use to do surgery needs to be sterilized as well. So all those same paradigms, your digitization, your data and AI, and the feedback loop of analytics, all of those things apply to different verticals. So whether it's medical sterilization, food sterilization, oil refinement, like that. So this actually has a huge platform extension beyond water, which I think is really important for the investors to keep in mind.
Yeah. Yeah, right. So I think there's one more question here. I guess a little bit to all of us on how these solutions differentiate from existing desalination and filtration systems in terms of energy efficiency, maintenance cost, and scalability. I think we answered a little bit of that in terms of the energy efficiency. For sure, is lower than at least the existing used technologies out there. Maintenance costs, I don't know, Fabio, do you have any on your filtration systems in terms of maintenance?
Yes, for sure. You have to do some maintenance, but you cannot generalize it, right? It always depends on the water quality, on the volume, on the water flux, and
And I think that's again the same with the water network, wastewater networks, and transport through the cities. Yes, there is maintenance, but what the digitization and these technologies do together is predict that maintenance, so that we are actually able to take it up front, right? And we know what's going on, and we continually monitor how these things are working. And that's a huge difference. And we can do it remotely, right? So even if it's in Tanzania, as Fabio mentioned, we can actually from Europe assist them and tell them when it's time to do their cleaning or to change parts. And the Pulse system is shipped in a single, was it 20-foot or 40-foot container? I forget, Rania, but it's an integrated system. And with few moving parts actually, right? So again, something that is easily maintained. So I think we are. The combined solution here is really scalable. We just need to prove it, and so that's why we need your help, guys. I mean, because at the end of the day, when I've been pitching this to other people, they say, "Why isn't everyone just buying this stuff?" And it is a bit strange, but it is because it is a conservative business, and everybody's looking for proof that it works. Even though it works next door, doesn't mean it works in their municipality or their city, and that's why we need a little bit of help in really scaling this up quickly. Because the impact is there, and each of these technologies in their own right is better than what you see out there in the existing market. So I think with that, actually, we are a little bit over time already. I don't know, Maria, how long we can go on for, but I also don't see additional questions in the chat.
No,
So I think any closing remarks, Fabio? Or...
No, I loved the quote which we learned from Earth05 that in water we find unity.
Yeah.
And yeah, let's make every drop counts. Together we can achieve even better than when we do it alone. And that's why I love this format and then the platform. And I'm happy for everybody. Yeah.
Yeah. And we're learning a lot actually from each other in this co-creation kind of format, right?
Yeah.
We come from different markets and different backgrounds, but
different perspectives.
Different perspectives,
Yeah.
exactly. Yeah.
But it really is all the same vision. It's the same vision, really. This is a beautiful civilization changing moment for everyone. So I'm really happy to be a part of this.
Definitely. Right. So with that, I guess we're wrapping it up for this session. But please don't be strangers. Keep asking questions. All of us individually or together, and we hopefully will meet some of you interested people later on. Thanks a lot for the attending this, and all the best for the rest of your day.
Thank you.
Thank you. Thank you all. Bye bye.
Bye bye.